Hi, welcome back. It's Mr. Hannah here. We're doing the second part of factorising. We're learning the delightful method of completing the square. Okay, so first let's think about what a square is, a perfect square. Let's do this with an example. So here let's do an expanding example to help us out. So let's say expand x plus 4 squared. Okay, well x plus 4 squared is just x plus 4 multiplied by x plus 4. So our A and our B are 4 in this case. So that must be, sorry about that. Okay, it must be x squared plus, first you add them, 4 plus 4. So 4 plus 4 is 8. X, multiply them. 4 times 4 is 16. X squared plus 8x plus 16. So let's write a general formula now for a perfect square. So expanding a perfect square is when we've got x plus a number and we're squaring it. Okay. And when we expand that, it's x squared plus, well, 8, that's just double 4, so it's 2 times ax. And then the last term is a squared. A squared. So there we go. So there's our perfect square expansion. And it's basically the same as the last one with the a and the b, except both of them are a. Okay, so that's pretty easy. So let's do the first example of completing the square. So let's look at example 1. Okay, so we want to factorize x squared plus 2x plus 1. We want to factorize this. Well, firstly, I guess some of you might be tempted to use the thinking about it method. Know that to get plus 1, you can do 1 times 1, and 1 and 1 adding together is 2. So you already know the answer, but we're doing completing the square, so we can use this formula here for perfect squares to see if it fits into our equation. And it turns out it does. See, if we have a from here being 1, then this is a perfect square. So straight away we can write this is a perfect square with a being 1, so it's x plus 1 squared. Because we've noticed that the 2 is double that of the square root of this squared. Let's do another example to try and make this a bit more clear for you. Example 2. Okay, let's try x squared plus 6x plus 9. Okay, hopefully here you can see it a little bit more clearly. 9 is like the a squared. So here we could write this as 2 times 3, that gives us 6x, and the 9 would then be this middle one squared plus 3 squared. And it turns out that 9 is 3 squared. So this works perfectly well as a perfect square with 3 being our a. So it's x plus 3 squared. Okay, so hopefully those two examples show you kind of what we're aiming for here. Now you'll notice that we could have just used the thinking about it method for this one. We could have just said what are factors of 9? Oh, 3 and 3. 3 times 3 gives 9, and if we add 3 and 3 gives 6. So that one does work, and we've got it straight away using the thinking about it method. So with that in mind, why do we need this perfect squares method? Well, let's do an example that shows you why we do need it. Let's suppose with example 2 we had something different, x squared plus 6x plus plus 8. Okay, now we can't use the thinking about it method because the factors, actually yes we can, that's frustrating. Sorry, let me change that 8 plus 8 to a plus 7. There we go, that's much better. Now we can't because the only factors of 7 are 1 and 7, or -1 and -7. If you add 1 and 7, it gives 8, which is not 6. If you add -1 and -7, it's -8, which is not 6. So we can't use that. We can't use the thinking about it method. But we can use completing the square. And this is how we do it. First we look at this middle term and we change it so that it's in the same form as our formula. So it's x squared plus 2 times 3x. So here 3 is our a in our formula. 3 is our a. Now if the n term was a squared, so it needs to be 3 squared. So it needs to be plus 9. But it isn't. It's not plus 9, it's plus 7. So if we're going to add, we wish that it was plus 9. So we'll put our plus 9 in, because we wish it was that, but then we'll take away 9, because you can't just add in plus 9 for nothing. You have to also take it away. So overall, you've added in nothing. Now we've also got our plus 7. We can't just forget about it. We've got to keep it, plus 7 there. So now, I want to draw your attention to the fact that this bit here, whoops, is the same as our example 2. The bit is the same as our example 2. So, just that underlined bit will become x plus 3 squared. It's a perfect square. So we've completed the perfect square by adding this plus 9 term. Now we can't just go and forget about this other part, the minus 9 plus 7. We've got to include that as well. So if you combine minus 9 plus 7 is minus 2. So there's a minus 2 out here as well. So there we go, that has now been factorized. There we go, it's been factorized. Okay, we can go further, but I want to leave it there for now and do another example because I think a lot of you will find that very confusing the first time you see it. So let's try another example, example 4. X squared plus, let's see, plus 8x plus plus 10. So once again, this one cannot be factorized using the thinking about it method. So we need to do completing the square. So first we'll change our 8x into, so it looks like this. So we'll take out the 2. So that equals x squared plus 2 times 4x. So our a here is 4. So now we need to complete the square by putting in a 4 squared term. So 4 times 4 is, of course, 16. Now we need to take away our 16 because we can't just add it in for free. We've got to take it away again. Now we've got to include our plus 10 from before as well. Plus 10. So let's see, in blue now, this bit is a perfect square. That bit there is a perfect square. And this other bit's just sort of hanging around. So with the perfect square, we can factorize the perfect square. Oh, whoops, not grey. Factorize our perfect square, x plus 4 squared, and this bit's still hanging around, minus 16 plus 10, well, that is minus 6. Excellent. Now I might want to do one further example to really get this in your heads. Example 5. Okay, let's try a slightly harder one. X squared minus minus 10x plus 6. There we go. Okay, so once again, x squared minus 10. So we've got to make it a plus here because our formula's a plus. So plus 2. Now it's minus 5 there in brackets. X. Now our minus 5 times itself, minus 5 times itself is plus 25. Now we're going to take away 25, add our 6 from before. Okay, so with our bit that's a perfect square, we've got x minus 5 squared minus 25 plus 6 gives us minus, what is that, minus 19. Cool, there we go. So there are a couple of examples for you. Now, we can actually factorize even further. So you remember our, maybe I'll write it in green over here, our difference of perfect squares formula that we've remembered from last time, x squared minus a squared is x minus a, x plus a. Now, check this out. Let's look back to example 3 here that we had before. So we've factorized down, so we've got a perfect square minus 2. But 2, the minus 2 we could change to minus the square root of 2 squared. And this bit will leave the same, x plus 3. Now look at this, we've got a perfect square here, just like this x squared, and a perfect square here, just like a squared. So we can use our difference of perfect squares. So whenever we've written an x here, it'll be x plus 3. So x plus 3 plus root 2, and x plus 3 minus root 2. So now it's fully factorized. Here, this is pretty good. That's pretty good. This is fully factorized the full way. So let's just give that 3 ticks, I guess. So there we go. So you can try that as well for this one. So here we've got minus 6, so we can change the minus 6 into a minus square root of 6 squared. This bit will remain the same. Squared. So now it's x plus 4 plus root 6 and x plus 4 minus the square root of 6. So this one, that was pretty good. This one is now extremely good. 3 ticks. Okay. For example 5, I'm actually going to change this just to be a real pain in the backside to plus 26 instead of plus 6. Let me just change my example, plus 26. Because now what would happen is instead of minus 19, I've got minus 25 plus 26. So instead of the minus 19 at the end, I'd have a plus 1. Now the reason I've changed this example to be plus 1 is just to illustrate a point, which is here, but plus 1, that is not, we can never have minus a squared because of this plus sign. Because of this plus sign, it's not a minus sign, and so we cannot go this full way. You can't go that full way. So this one is actually the triple tick. That's as good as you can possibly do for that altered example now with the plus there. So that's as good as you can do. You can't fully factorize that one. Alright, thank you very much for listening. See you in class.